All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still doing our Understanding VITs module. Let's have a look at what we went over today. And we still haven't made it to any code yet, so we're still just taking notes. So I can walk you through the notes we took today. Let me take it to the top, see exactly where we started. So we started around here. So yesterday, you remember we did the importance of the actual R and R neural networks and the importance of those are. So we're just going to go over some more examples of why that's important, and then go over more use cases and dive deeper into the R and R's. Oh, R and N's. Sorry about that. So the importance of passing the computations from one block to another is that each token's computations will depend on all the previous tokens. Once we are done passing information from one block to the next, we are going to take the last block, which should hold all the computations from the previous blocks, and pass it to the next section of R and N blocks. Let me go up really quickly and show you exactly what that would look like. So again, we're taking all of the information or computation from this block, passing it to this block, taking all of that, passing it to this block, taking all of that, passing it to this block, taking all of that, passing it to this block, and finally, we'll take all of that information accumulated as one and pass it to this new section of blocks here in our target. So this will be our source. We will take all of that information gathered in our source and pass it over to our target into this first block here, which in turn will do the same thing that it was doing over here. It'll do all of its computations and get passed to the next block, which will get compulated and passed to the next block, and so on and so forth. So basically, that's what we're saying there. So let's go back down for a second, see exactly where we were. So this is our encoder block, the R and N, where the computations are coming from, also where our source text is. The next section of R and N blocks will be our decoder, the R and N where the computations are going, also where the source is translated, like I explained to you. And again, a similar process is repeated when we are on a decoder. Like I also stated, we're just going to do more computations and pass those on to the next blocks. We will have computations which will produce an output, which will get passed to the next block, and so on and so forth up until the final output. But then the problem with this technique is that the image we have, or the problem with this technique is, imagine it's supposed to be, imagine we have a very long text, then it might happen that it becomes too difficult for information to flow from one block to the next block, which is important for previous context to be passed to neighboring blocks. So let's say if we go back up again and have a look at these blocks, let's say we have a very large text. Oh, our block said here, our block said, let's say we have a very large text, there are a bunch of words. So we may start out with a small compilation or computation or just this one here, but by the time we reach the end of the text, it may be such a huge computational file that it might be hard to actually translate that from our source over to our target. So that may cause, or that may result in errors actually in moving the information from one place to another. So that's one of the drawbacks we were talking about. So let me see again where we're at here. So yeah, like I said, imagine we have a very long text and we're trying to move information from one block to the next, which is important, getting the context from the previous blocks. So without the context from previous blocks, this problem will lead to poor results. Another problem is that each time we train, we have to pass information from one block to another sequentially. Because the information gets passed sequentially, it makes it difficult for us to implement parallelization very efficiently. So this makes the training of these kinds of neural networks very difficult. To tackle the issue with long-term dependencies, attention networks will develop. So instead of depending I'm sorry, let me see, I moved down too far, too fast. So instead of depending on just the final output we get from the hidden layer, which gets passed to relay information from the source to the target language, what we'll do is for each and every unit we have, each and every recurrent neural network block we have, we are going to take into consideration inputs from each and every block. For example, inputs from each and every block from our encoder will get passed to the first block of the decoder. We didn't have an attention layer which processes the inputs from the different source R and R blocks and produces an output vector, which is now passes input into the target R and R block. Now let me show you what that looks like finally. So you can see here. So with this method of attention, all of these blocks here, though weather today is amazing, all of these computations will get compiled as one and get compiled into an attention layer. That attention layer will get fed into just the first block here. So it won't get fed into all of the blocks as a whole. All of the other blocks, it'll get just fed into this first block here. So all of these, It'll get computed the same way as it always does. It'll take one piece from here, it'll go here, it'll take one input from here, it'll go here, and so on and so forth until all of the inputs are added into this first block. Now again, this entire computation will get passed into the second block here, but also it'll get an attention layer also. So again, we'll have another attention layer and an input from the first block, an input from the second block, an input from the third block, an input from the fourth block, and an input from the fifth block will get passed into the attention layer, and that attention layer will get passed into the second block here. So the second block will not only receive all of the computations from this first block, it'll receive computations from the layer that receives inputs from each and every one of these blocks. Now again, I know that may have went over your head if I went a little too fast, but the more we do it, the more you understand it. And that's what we did today. All we did was take notes. Like I said, we didn't start any new code yet, so we're just going to be doing some understanding and taking notes until we're ready to move forward and actually implementing some code on our own. But of course, I will keep you posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.